Good morning, my dear students. Till now, we have studied about Cartesian coordinate system, plane polar coordinate systems, and we have studied the motion of a particle in both Cartesian coordinate and in plane polar coordinate. Now it's a time to discuss about spherical polar coordinates and the motion of a particle in spherical polar coordinate. But before going on to the motion of a particle, we need to study about the unit vectors of spherical polar coordinate, since you are already aware that the unit vectors of spherical polar coordinates, they are not static, they are changing. So the unit vectors corresponding to the spherical polar coordinates, that are r cap, theta cap and phi cap. We need to discuss all these three unit vectors of spherical polar coordinates. So let us quickly have a vision for the spherical polar coordinates. Let us suppose this is my y-axis, this is x-axis, this is z-axis. As we have already discussed that we have a point P over here such that the position vector r is making an angle of theta with the z-axis, and the projection of this position vector, say this is rho, and it is making an angle phi with the x-axis, such that if I draw a perpendicular from here and to here, so that this is, let us suppose, my A point, N point, B point, and since this is a part spherical polar coordinate and cover a part of a sphere, so I can always draw it like this. This is a part of a sphere. Now my r vector, so corresponding to this r vector, I will be having a unit vector r cap. So unit vector will be along the direction in which my position vector will be increasing, and similarly my theta cap will be in the direction in which my theta will be increasing. Say my r is increasing in this direction, so my r cap will be in this direction. My theta cap is increasing in this direction, since theta is going clockwise, so theta cap will be like this, and my phi is going anti-clockwise, so phi will be going like this. So but if we see, then r cap, theta cap and phi cap, they are perpendicular to each other. This is the primemost property of spherical polar coordinates, unit vectors. So first of all we will find r cap unit vector, then we will find theta cap unit vector, and then we will find phi cap unit vector. We can clearly see here that r cap unit vector, that is in the z-o rho plane. Your theta is also in z-o rho plane, and your phi is in xy plane. This is my O point, that is origin. So let us first consider xy plane. This is my y, or this is my x, this is my y. This is my rho axis, and it is making an angle of phi with the rho axis, and rho axis, the unit vector of rho axis will be my rho cap. So before getting the r cap unit vector in z rho plane, I need to find rho cap value, rho cap unit vector. So what will be my rho cap? Rho cap will be, here the unit vector corresponding to x is I cap, it is j cap, and this is k cap. So here the unit vector is I cap, here the unit vector is j cap. Now rho cap will be equal to component of unit vector I cap along rho cap plus component of unit vector j cap along rho cap. So here my I cap is making direct angle phi with the rho cap axis. So it will be my I cap cos phi plus my j cap is making an angle of 90 minus phi with the rho cap axis. So it will be j cap cos 90 minus phi. So value of rho cap will be I cap cos phi plus j cap sin phi. So this is my unit vector along rho axis. Now let us move on to the another plane, that is my ZO rho plane. This is rho, this is Z. Suppose this is my P point making an angle theta. So I can clearly see here my unit vector is rho cap, here your unit vector is k cap. Now your r cap vector, I need to find the value of r cap in ZO rho plane. Since you can clearly see from the diagram that your r cap lies in ZO rho plane, your theta cap also lies in ZO rho plane, and your phi cap lies in XY plane. So in ZO rho plane we can see what is your r cap. R cap is the component of unit vector rho cap along r cap plus the component of k cap unit vector along r cap. So I can see r cap is making an angle of 90 minus theta with the rho cap axis. So rho cap into cos 90 minus theta plus j cap k cap cos theta. So this will be my rho cap sin theta plus k cap cos theta. Let us suppose this is my 1 and this is my 2, number 2 equation. I can put 1 in 2. So you will see r cap is I cap cos phi j cap sin phi into sin theta plus k cap cos theta. So open the brackets, you will get I cap sin theta cos phi plus j cap sin theta sin phi plus k cap cos theta. So this is my r cap unit vector. So this is what I was about to find. What was the value of unit vector r cap? Now similarly we can move on to theta cap value. For theta cap value, I know that my theta cap will increase in the direction of increasing theta. So if my theta is increasing in this direction, my theta cap value will also increase in this direction. So this angle will be my theta and this whole angle Since r cap and theta cap, they are at 90 degree to each other. So now what I need to find is, I need to find the value of theta cap. So theta cap is component of, since I am dealing with two unit vectors now again. So component of unit vector rho cap along theta cap plus component of k cap along theta cap. Now rho cap is making an angle of theta with the theta cap. So I can write rho cap cos theta plus k cap, that is, it is making an angle of 90 plus theta. So this is cos 90 plus theta. So what is my rho cap? In the earlier one I found this is cos phi plus j cap sin phi into cos theta minus cos of 90 plus theta, that is minus sin theta, minus k cap sin theta. So open the brackets, I will get I cap cos theta cos phi j cap cos theta sin phi minus k cap sin theta. So this is my theta cap value. Now I want to find the value of phi cap. To find the value of phi cap, I will have xy plane. So this is my x, this is my y. This is making an angle of phi with the rho axis, and now phi will increase in this direction. This will be my phi cap. This is my x, I cap. This is my y, this is j cap. Now this angle is, total is 90 between I cap and j cap. Now this angle is also phi. Now I will see the angle that j cap makes with phi cap and the angle that I cap makes with phi cap. So my phi cap will be component of unit vector I cap along phi cap plus component of unit vector j cap along phi cap. Now since I cap is making an angle of phi plus 90 degree, so it will be I cap cos 90 plus phi plus j cap is making direct angle phi with the phi cap, so it will be j cap cos phi. So cos 90 plus theta, that is minus sin theta, minus I cap sin phi plus j cap cos phi. So this is my phi cap. So these three are the unit vectors for spherical polar coordinates, that are r cap, theta cap and phi cap. Now we have studied about the property of spherical polar coordinates, that is all the unit vectors of spherical polar coordinates, they are orthogonal to each other. What does it mean? We can either prove it with the dot product or we can prove it with the cross product. So if I want to prove that r cap, theta cap and phi cap are orthogonal to each other, what I will prove is, I will prove either my r cap dot theta cap is 0 or my theta dot phi is 0 or my phi dot r is 0. Or if I want to prove it with the help of cross product, then what I will do is r cross theta equal to phi. I will prove this. Theta cross phi is equal to r and phi cross r is theta. Now since I am having the values of r cap, theta cap and phi cap, so I will clearly write all the three values over here. This is my r cap. My theta cap value is I cap cos theta cos phi plus j cap cos theta sin phi minus k cap sin theta. This is the value for theta cap, and my third value is phi cap, that is minus I cap sin phi plus j cap cos phi. So I will prove these results. First of all, I will find the value of r dot theta. I will have a dot product for r and theta. So what will be my r dot theta? Since I know that my I dot I is 1, j dot j is 1, k dot k is 1, but if I multiply I dot j, j dot k, that is my 0 value. So I can write r dot theta. If I multiply these, so I will get, when I multiply I cap component, it will be, I'm directly writing the result. So it will be cos theta sin theta cos square phi plus j cap I dot I is 1 plus cos theta sin theta sin square phi minus k cap sin theta cos theta, and rest all the terms will be 0. Now this is my cos theta sin theta is common in first two equation. This will give me cos square phi plus sin square phi minus sin theta cos theta. Now since cos square phi plus sin square phi is 1, I can cancel out these terms. Cos theta sin theta minus sin theta cos theta, that is my 0. And similarly, I can do it for theta cap dot phi cap. I directly multiply. So it will be minus cos theta sin phi cos phi. This is when I multiply I dot I plus j dot j. This is cos theta sin phi cos phi. And since I don't have a k component, so I can't multiply it with, here the k component is 0. So when I multiply this, it will give me 0. So I can cancel out these. This becomes 0. Now for phi dot r. If I multiply phi with r, I will get minus sin phi cos phi plus components of j cos phi sin phi, and I don't have a k component in phi, so it is 0. So when I multiply r with r cap unit vector k cap, then it will be 0. So I can cancel out and I get phi cap dot r is 0. So this proves me these three relations. R dot theta is 0, theta dot phi is 0, phi dot r is 0. So it means my unit vectors r cap, theta cap and phi cap, they are orthogonal. And since I told you that we can also prove it with another method, that is the cross product method. So what I need to do is, I want to find now r cross theta. So I'll be doing it for one and you will be going for other two. So first of all, r cross theta. Since I know in case of cross product, your I cross j gives me k, your j cross k gives me I, and k cross I gives me j, and if I talk about I cross I, that will be 0, j cross j will be 0, k cross k will be 0. So apply these two. When I multiply I component with this whole equation, I will get, when I multiply with this, it will be give me 0. This will give me k cap sin theta cos phi sin phi, minus, here your direction is very important. Like if you are multiplying r is at the first place and theta is at the second place, it should remain like that, because if you reverse it, then you have to change the sign also. So r cross theta we are doing. So r is at a first place. Now if I multiply I cross k, it will give me minus j. So this is minus minus plus, plus sin square theta cos phi j cap, second bracket is j cross I, that will give me minus k. So minus k sin theta cos theta sin phi cos phi, j cross j is 0. So j cross k give me I minus I sin square theta sin phi I cap. Now similarly for the k cap, k cross I give me j cos square theta cos phi, k cross j give me minus I, this will give me cos square theta sin phi, and k cross k will give me 0 in the third part. Now if I see sin theta cos theta, I can cancel these. Now I am left with sin square theta cos phi sin square theta sin phi. Now if I collect the j terms, j cap terms in one bracket, I will get sin square theta cos phi plus cos square theta cos phi plus I cap in one bracket, so I take minus out, it will give me sin square theta sin phi plus cos square theta sin phi. Now j cap, if I take cos phi common, cos phi from here, I will get sin square theta plus cos square theta, that is 1, minus I cap sin phi, this will give me sin square theta plus cos square theta 1. So I am left with minus I cap sin phi plus j cap cos phi. So this is equal to my phi cap, value of unit vector phi cap. So it means I have proved that r cross theta gives me phi cap unit vector. So this was with the cross product. Rest 2 is your assignment. You can do yourself, that you can prove theta cross phi is r cap and phi cross r is theta cap. So this is all about the unit vectors. Thank you.